So let's see how to build a thermometer. So I'll give you guys a basic overview from my end, and you guys can build on that actually. So first thing is we need to understand what is important for us, as in what range of temperature is important for us. So decide on, again, this is my own flow. Like for this moment, I think this is what is needed. So I'm just going with my flow. Decide on what is important for us to measure. So me, the most fundamentally living being per se, right? So me being a person or as a living being, I think that's a very fundamental thing that we have to look at us as a living being rather than anything else. So the most important thing that we need on the surface of the earth is, yes, water. So we can start off with water as something that we can has a reference as, right? We want to understand what temperature the water is, So we have to decide on what is important for us to measure. So it's important for us, for me at least, I think I'll start off with water. If I am a scientist, my benchmarks will be way different than what I'm looking at. So if I'm a doctor, then it would be something else. But me as a human being, I think fundamentally that's the starting point. So I can fit all of you guys under that category. Doesn't matter what background you guys might have or going to have, doesn't matter. So that being the starting material or the reference material for me. So what is the important temperature in water is what I look at. So what are the set of important temperature of water basically? So what I can think about it is your freezing point and your boiling point, right? So I'll measure the freezing point as 0 degrees Celsius and boiling point as 100 degrees Celsius. So this will be my starting point. So I want my device to measure from here to here. So this will be our benchmarks basically. So this two will be our benchmark. So that will be my first step. Step 2 is material. What material will I or can I use to build the thermometer? So that is another discussion. So I'll not go into that. Is it liquid, solid, or gas, and so on and so forth. So we have in detail explanation for that. So I'll not go into this. Then step 3 is once you have decided on that. So in this, after deciding on the material, you see what kind of value the material or what kind of property it has, value or property the material has for 0 degrees Celsius and 100 degrees Celsius, for example. So once I have this, I'll also study if it varies linearly. So that's where the calibration comes into picture. So I will categorize it as a calibration. So basically calibration is nothing but dividing the scale into parts. It will not be equal into parts. So this will help us to measure value between 0 degrees Celsius and 100 degrees Celsius. Like say I want 34 degrees Celsius, 56 degrees Celsius, right? So it will help us do it. For this, I need to see if the material is linear variation. Will it vary linearly or is it non-linear? So I hope you guys understand what is linear. Linear is a straight behavior, right? Y is equal to 2x. Those are linear. Non-linear can be this or many possibilities, infinite possibilities. Here too there is infinite possibility, but here there is more possibilities. It can be anything, or let me just give maybe this. No. Okay, I'll just go with that. So if it's linear, then it's a simple straightforward calibration. That is, I know the maximum, I know the starting, I know the ending. So this is the starting and this is the ending. That's my 0 and 100 degrees Celsius. Okay, so that will not change. Let's just say 0 degree, this is 100 degree, 0 degree, 100 degree. Now here exactly you will have your 50 degree. Okay, yes. But for this, it can be maybe below or above. So I'll just take it as 50 degree over here. So you guys are getting it? Then this would be your 25 and 75 and stuff like that. For this, 25 might be somewhere over here and 75 might be over there. So this will be non-uniform basically. The division is not uniform. For this it will be uniform. And once we have this, we have a thermometer, as simple as that. So again, it starts with deciding on what is important for us. Say if I am a scientist, my range of temperature is different. If I'm an astrophysicist, then the range is different. If I'm a doctor, my range is different. If I'm a doctor of some other, if I'm a scientist who's studying some certain life forms, then my study range might be different. Again, it depends. So my starting and the ending point will be different. So that will be my benchmark. Then I'll take a suitable material, right? And I'll study its behavior, value or property the material has. Let me write the word property. That's more apt property. So this property, when I tell, we saw that in the last video. So this can be with length, area, volume, resistance. It can be anything. So if it has a definite property, if we can rely on that, then we move on to step 3, calibrating. So some material can be calibrated linearly. Some material, it need not be. It need not behave that way. So these are your variations, and yeah, that's how you build a thermometer. That's the basic funda. So let's have a read. Choose reference temperature. A thermometer must first be calibrated using 2 well-defined repeatable temperature. Okay, the word repeatable is important. For example, ice point and steam point. So these 2 serves as our benchmark. I'm here. Choose a physical property that changes with temperature. Thermometer must rely on a property that varies with temperature. It can be length, volume, electricity, or pressure. Oh yeah, even pressure. Check the nature of the property. Is it linear, non-linear? If the property changes linearly with temperature, divide the interval between fixed points equally. If not, it will be unequal. Construct the Celsius scale. So mark the 100, 0 and 100. Divide the division between them as 100 parts. Each part is 1 degree, right? This creates the Celsius temperature. How you divide it? That depends. Again, is it linear or non-linear? So when I tell divide, it need not be of equal spacing. Depends. So generally we are moving away. You guys have seen we are moving away from liquid thermometer to other forms. The usable temperature range depends on the liquid and the gases, right? That is one thing. The limitation leads to development of gas thermometer and electronic thermometer as of today. Oh, gas thermometer is more. Okay, anyways. So why is that we are moving away from liquid thermometer? This is the reason. So anyways, we are seeing gas and electronic thermometer, and we'll see what is the advantage over there and how to build it. So you guys, I think this is good enough for you guys to, yeah.